A very good morning, my dear children. Today I am going to make you understand first physics followed by mathematics, C, 5C and 5D exercise. Along with that, some of the doubts of 5B if you have, you can also ask to me that one. Today we are going to learn the optics chapter. Optics chapter is comprised of 3 parts under it. Optics are called light chapter actually. A light chapter is one of the unit under physics. It is comprised of 3 chapters. One is refraction, refraction of light at plane surface. Number 2 is refraction of light through lens, and number 3 is dispersion. There are the 3 chapters we will be learning in this chapter, in this module. The first chapter is our refraction. Refraction of light at plane surface. Now question comes, what is refraction? Before going to refraction, you should know what is reflection first, and what are the laws related to the reflection. Reflection means the phenomenon of bouncing back of light, when a light strikes, to a reflecting surface, just like mirror you can take. Reflecting surface is a mirror, or a polished surface you can take an example, just like the utensils also sometimes when you are cleaning the utensils. So it is this phenomenon of bouncing back of light when a light strikes to a reflecting surface is known as reflection. Just like in the previous classes we might have seen in the class 9th also reflection was there. So when a mirror is there, a polished surface, a light is striking to it with a certain angle, then with the same angle it is also reflecting in the same medium, medium also remaining same, that means air or water, what is the molecular, what is the medium, that remains same. And this is called as the first ray is the incident ray, and this is the reflected ray, and this one is a normal ray. And the laws related to it are the laws. First law was the incident ray. Here's the law: incident ray, the reflected ray, the normal ray at the point of incidence all lie in the same plane. And the second law states angle of incidence is equal to angle of reflection. Here is the definition of the refraction: the phenomenon of bending of light when it passes from one transparent medium to the another transparent medium is called refraction. But here we can also say that the phenomenon of change in direction of path of the light when it passes from one transparent medium to the another. An example I have shown, this is the medium in contact with the first medium, and the second medium is there. When a light is traveling from the first medium to the second medium, how much this is the refracted ray, this line is the refracted ray, and there is a partial reflection, maybe 3 to 4% of reflection, the rest all undergoes refraction when it travels from the one medium to the another medium. And if you produce the incident ray forward, then how much it is differing in angle from the refracted ray to that इंसिडेंट रे प्रोड्यूस्ड फॉरवर्ड इज द डेविएशन. इतना बेंड हो गया ये हमारा लाइट, जब एक मीडियम से पहला मीडियम से दूसरा मीडियम की तरफ लाइट रे जा रहा है, तभी इतना हमारा अंतर आ रहा है यहाँ पे जितना एंगल से, इससे बोलते हैं डेविएशन और एंगल ऑफ डेविएशन. बट ये बेंड क्यों हुआ, किस लिए हुआ, एंड रीज़न क्या है, ये नॉर्मल की तरफ क्यों गया, क्यों नहीं ये नॉर्मल रे के से दूर क्यों नहीं गया, ये सब रीजंस इसका स्पीड के ऊपर डिपेंड करता है. चलो पढ़ते हैं causes of refraction and 3 cases of refraction in the space. And now the 3 cases. The first case is case number 1, when a light ray is moving from rarer medium to denser medium, जब ये rarer medium से denser medium की तरफ जा रहा है तभी एंगल ऑफ इंसिडेंस जो भी रहता है, एंगल ऑफ रिफ्रैक्शन थोड़ा कम हो जाता है यहाँ पे. दैट मीन्स द refracted ray is moving towards moves towards the normal ray. This is the observation. We find that when a light ray is moving from denser to rarer medium, then the refracted ray is moving towards the normal. But if you see the second case, when a light ray is moving from denser to rarer medium, then it is moving away from the normal. It moves away from the, what is the observation? Refracted ray refracted ray moves away from normal, moves away from normal ray. This is the second case. Case 2, when the light ray is moving from denser to rarer medium. Then, and case 3 states that if a light ray is moving from rarer medium to denser medium normally, or denser to rarer, that is vice versa, when light ray passes from rarer to denser or vice versa normally, then it goes undeviated. That means it moves in the same path. Here the normal ray is this one and the incident ray is also this one. That means both the rays are coinciding to each other. That's why the angle of incidence is 0 and angle of refraction is also 0. But in this case, angle of incidence is much more than that of the angle of refraction. In second case, we have observed that angle of incidence is less than angle of refraction in two cases. But in the third case, we have observed that angle of incidence is equal to angle of refraction, that is equal to 0. So what is, now the question is coming to our mind, what is denser medium, what is rarer medium, and why these light rays are bending when they travel from one medium to the another medium? This is the question, it comes to our mind. Let me tell you the answer for this. Now if I would give the differentiate between optically denser medium and density of the medium. Now we have discussed with case 1, case 2 and case 3, there those mediums we are discussing, that is optically denser or optically rarer medium. We are not discussing about this density of the medium. That means optically denser medium means it depends upon the speed of light in the medium. कितना speed में light उस medium पे जा रहा है और पास कर रहा है, उसके बारे में हम लोग पढ़ रहे हैं. भले ही हम लोग जानते हैं डेंसिटी का मतलब होता है कि कितना, जैसे ही मॉलिक्यूल्स होते हैं कितना क्लोज है. डेंसिटी ऑफ द मीडियम डिपेंड्स अपॉन इट्स इंटरमोलिकुलर स्पेसिंग. इंटरमोलिकुलर स्पेसिंग के बारे में यदि हम लोग पढ़ते, जो कि हमारा केमिस्ट्री में है, वो डेंसिटी के बारे में बताता. बट यहाँ पे हम लोग यदि बोलेंगे कि एयर मीडियम, वाटर मीडियम, वी आर नॉट डिस्कसिंग अबाउट हाउ क्लोज और हाउ फार आर द मॉलिक्यूल्स हियर. We are going to discuss, or we are discussing about the speed of the light in that particular medium. जैसे कि मैं एक एग्जांपल देना चाहूँगा आप लोगों को. ऑप्टिकली डेंसिटी का मतलब भी ऐसा होता है कि बिकॉज ऑप्टिकली डेंसिटी एंड डेंसिटी ऑफ द मीडियम आर नॉट हैविंग एटलीस्ट 1% ऑफ रिलेशन. जैसे केरोसिन इज लेस डेंसर. केरोसिन इज लेस डेंसर मीन्स केरोसिन इज फ्लोटिंग इन द वाटर. बट ऑप्टिकली डेंसर देखा जाएगा, ऑप्टिकली डेंसर के हिसाब से केरोसिन इज मोर ऑप्टिकली डेंसर देन दैट ऑफ द वाटर. ऑप्टिकली डेंसर मीन्स केरोसिन के अंदर और भी स्लो होता है हमारा लाइट. लाइट मूव्स वेरी स्लोली इन केरोसिन कंपैरिजन टू दैट ऑफ द वाटर. हियर स्पीड ऑफ द मीडियम. Since speed of the medium is one of the factor upon which the refraction depends and upon which the density of the medium also depends. So if we'll see the optically denser or rarer medium, so optically rarer is air because speed of the light in air is 3 into 10 to the power 8 meter per second. Speed of the light in water is 2.25 into 10 to the power 8 meter per second. Speed of the light in glass is 2 into the power 8 meter per second. This means we are finding that air is rarer than that of the water, then that of the glass. The water is rarer than glass. If I would compare Air is rarer than water and water is also rarer than glass. If you see denser, glass is much more denser than that of the water and water is denser than air. Now causes of refraction. Refraction occurs due to the change in speed of light when it moves from one medium to the another medium. That means case 1 में आप लोगों को याद होगा मैं बताया था, if it passes from rarer to denser medium, the speed of light slows down. Thus refracted ray moves towards the normal. इसलिए वो नॉर्मल की तरफ जाता है क्योंकि यहाँ पे स्पीड कम हो जाता है. एग्जाम्पल देखा जाए तो एयर टू वाटर बोल सकते हो, एयर टू ग्लास भी बोल सकते हो और वाटर टू ग्लास भी बोला जा सकता है. Here the case 2, when light ray is passing from denser to rarer medium, then light ray moves away from the normal. That means we have already learned denser to rarer medium, the light ray is moving away from the normal because speed of the light is increasing there. That's why. Some example like glass to air, you can say glass to water, you can see water to air, you can also are some examples from one denser medium to the rarer medium. But case 3 was saying if light ray is moving normally, then it is not changing from one to another medium, doesn't change its direction. What is the case for here? Why the light ray is not changing? Because the light ray is perpendicular. If the light ray is only obliquely, if it is moving from one to another medium, then only it changes its direction. But if it moves perpendicular, then it will not change its direction because its angle of incidence is also 0, with the angle of refraction also makes 0 here. Some laws of refraction I want to state you. Incident ray, normal ray and the refracted ray at the point of incidence all lie in the same plane. The first law, second law is stated as Snell's law also. It is stating that the ratio of sine of angle of incidence plus angle of refraction is equal to constant of the second medium with respect to the first medium. And one more factor I want to state you as frequency. Frequency is one of the factor which does not change of the light when it moves from one medium to the another medium, and frequency depends upon the speed of the light of the medium and the wavelength of the medium. So I am sending the video and followed by I am going to teach you from a refractive index tomorrow, and I will also prepare some questions for you all. I am sending the questions too. Please write its answer on the day of opening. I will see all the answer from today's date onwards. So please put the date of yesterday and go on writing all the answers, and I will check all the homeworks on the date of reopening of our institution.